Welcome you all to the week 5 problem solving session of Advanced Calculus for Engineers. Myself Guru Bhajan from Department of Mathematics, IIT Jodhpur. I am working in the broad area of tactile geometry and dynamical systems. In today's problem solving session, we start the differential equation. That means we are going to do formulation of differential equation. We learn about its order and degree. Then we deal with first order and first degree differential equation. Then the exact differential equation. Then we will learn the approach how one can solve the differential equation via integrating factor. And then the last we conclude the session with linear kind of differential equation. So first of all, let us recall what is the differential equation. Let me formally write it. Differential equations. So first of all, anyone want to comment over what is differential equation? What is differential equation? Let me
Like
write it. Manas,
partial and
your voice is breaking.
custom answer.
Okay. An equation involving derivatives of one or more dependent variables with respect to one or more independent variables. So it may be variable or variables is called a differential equation. So in short, we write either differential equation or DE. So let us see some examples. First one is plus d2y dx square is equal to e to the power x. Second one is y square plus 1 dx plus x y square minus 1 dy equal to 0. And the third one is del v by del t square is equal to k times del cube v by del x cube whole square. So now tell me, out of these differential equation, which one is OD and which one is PD? OD means everybody aware about what is OD and what is PD? See, OD means you have only one independent. Yes, please, Manas, you want to say something?
Yes, sir. No. First and second are ODE. Third one is
PD.
PD. Yes, sir.
So these two are ordinary differential equation, and this is partial differential equation. Why? Because in the third one you can see there are two independent variable, one is t and one is x, and v is the only dependent variable, so it is depending on two variables. So we also writing rather than d here del, so that means this is a pd. The equation, the differential equation which depends on more than one variable will be called as pd. Otherwise, if it is depending only one independent variable, then it is called as ODE. Now, what is the order and degree? What is order and degree?
Order is like first derivative it is or second derivative it is or what it is. Like in first order is 4 and
So,
degree is the power of highest order derivative. Like
okay.
d4y by dx t power 4. Then here degree is 1. Fourth
So,
order, first degree.
okay. So, in the first one is order is 4 and degree is 1. What about this one?
Both 1.
Order is 1, degree is 1. And the third one, can we comment order or degree?
No.
Why?
Two.
See,
Okay, we have to go with higher one. Okay, okay.
definition remains same, na?
Okay, okay. We have to 3 and 2. 3 and 2. My bad.
3 and 2. So let me explain. Order is the highest order, highest order derivative that is occurring in the differential equation. If you observe, here is the highest order derivative, that is 4, that is occurring in the equation. That is why order is 4. While seeing the degree, you need to make sure that your differential equation is free of radicals and fractions. So radicals means whenever, suppose there is a term like sine dy by dx equal to suppose y, or you can say something that cannot be solved, x plus y. Now can you tell about the order and degree? What will be the order and degree?
No, we can't comment.
Why?
It is in sign.
So
So we have to free it from sign.
at least order we can tell, I guess.
Order, yeah, order we can tell is first, but degree we can't say like this.
Okay, for degree we cannot comment, but what if I would say,
Sign inverse. Yes. Then we can say it like 1.
in this case we can say it 1,
Say it. Yes, sir.
because if you will recall that expansion of your sin x, uh, then it will go till infinity, so you cannot comment about degree in this scenario. So now come back to this example. So in this you can see that there is only first derivative is occurring, and obviously the highest power of the derivative is 1, so order is 1 and degree is 1. In the similar kind, in this differential equation, your highest order derivative is 3 with respect to x, so order will be 3 and degree will be 2 because it is being squared. Now it's about the differential equation of order or degree. Now what is linear differential equation? See, there are classification of differential equation. Now one is you have done with respect to, you can say, ODE or PD. Now what about linear or non-linear? How will you decide?
Linear as clear, like with degree 1. and
Degree 1.
non-linear with degree more than 1.
So everybody agrees with this. Degree 1. See, that is true that your dependent variable and independent variable should be in first degree only. But there is one more thing. There should not be product of dependent variables and derivative dependent variable with the derivative. For example, if there is some term y dy by dx, could you say this is the differential equation? Linear? Is this linear?
No, 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 no.
Okay, so this is first degree, but it's not linear. So that means you need two things. One is, so one is that every dependent variable and every derivative occur in first degree, and second one is no product of dependent variables or derivatives occur. Is it clear? Now what is non-linear? It will be then obvious. Whenever the product is occurring, or you can say power is more than one, it is, you can say, non-linear differential equation. So if I am giving you one example, d2y dx square plus y dy dx plus y equal to 0. Now tell me, what is the order and degree, and is this a linear or non-linear?
Order 1, degree 1, non-linear.
Order 1. Are you sure order is 1?
Oh, sorry, sorry, sorry. My order is 2.
Order is 2, degree is 1,
Degree is
and
1 and non-linear
non-linear. Why non-linear?
because it contains the term y into dy by dx. And
Because of this.
by doing any manipulation, we can't just free it from
Yes.
this.
Now what is the solution of the differential equation? What is the solution of the differential equation?
It is a function related to dependent and independent variable, like y is equal to f of x, which satisfies this given differential equation.
Correct. So any relation between the dependent and independent variables, no derivative should be there. This is necessary. No derivative terms. In solution, there should not be any derivative, which satisfies the given differential equation is called a solution of the differential equation. Now next is, what is family of curves? Anyone? What is family of curves?
The general solution for the differential equation that contains arbitrary coefficients,
Arbitrary
C1, C2, and all.
that is called as family of curves.
Yes, sir.
So family of curves. So n parameter family of curves is a set of relation of the form all those xy such that fxy, since we are saying n parameters, so there will be n arbitrary constants, cn equal to 0. Now how can one formulate the differential equation? This is our first task for today. Formulation of differential equations. Tell me how one can formulate differential equation. Let me complete this one. From a given n parameters family of curves. So obviously we know that our family is depending on n arbitrary constant or n parameter. So to get the differential equation, we need to eliminate these n parameters from the family of curves. So that means you need to differentiate
N times.
n times to family of curve equation, or you can say to this fxy c1 to cn to 0 to get n more equations. Already you are having an equation, now you have n plus 1 equations. So what is the left task? Eliminate
Constants.
n arbitrary constants.
Constants.
Then resultant will be differential equation of nth order. This will be your resultant. So we will do this one with the help of one example. So before that, let me give you one question regarding the linearity and non-linearity of a differential equation. Then we will do how one can get a differential equation from a family of curves or family of curves. So consider the differential equation One is d2y dx square whole square 5 times dy by dx equal to d3y dx cube plus sin x. I am calling this equation as P. The another one is dy by dx plus xy is equal to x e to the power y. This is something q. Now tell me about order, degree, or you can say linearity, non-linearity, everything that is possible.
Sir, first one degree 3, sorry, order 3 degree 1.
Correct.
And non-linear.
Comment.
Second one,
Non.
second one also order one, degree one, and linear.
Order, degree, linear. Second one is linear.
Yes, sir, linear.
Very good. There is a term e to the power y. Still it is linear.
No.
Manas.
It is.
Very good. Then why here this is degree not defined, or you can say this is not linear.
Dy by dx is inside the sine function. And
What is written here? No product
yes,
of dependent
with the derivative.
variables. Dependent
There is
variables also. There is a slash condition. Y
no
square should
product of dependent variable
variables.
or dependent variables.
Yes,
Okay, depend.
y square, y cube, y to the power 4 can also not occur. This is not a linear differential equation in that scenario.
Okay.
Now tell me, still degree is
One
1, and because of
sine and power two.
no sign with x na, we have
Oh yes, sine power two, power two.
yes, non-linear. Next one is
Sir, non-linear due to the presence of e to the power y.
yes, I'll explain why. Order is 1,
One degree is one.
degree is 1, and this is non-linear because there is a term e to the power y. What it will affect, you cannot separate y obviously, so it will be a, like this kind of
Hmm.
series. If you can separate, like the previous case, there was equation sine dy by dx is equal to x plus y. In this case, you can separate dy by dx as sine inverse x plus y. Can you say that this is a linear?
No.
This is again not linear with the same reasoning.
Expansion of sine inverse of x.
Wait a second. How
Sir,
did
from the
you
expansion.
comment about this is non-linear? Manas, expansion of sine dy by dx, not expansion of sine inverse.
Mm.
So here e to the power y is the playing a key role to prove that, yeah, to show that this given differential equation is non-linear. Okay, now how to formulate this non-differential equation? Obtain the differential equation from y is equal to e to the power minus ax sine bx plus cos bx. Quickly tell me the differential equation. How many parameters are there?
Two parameters, A and B,
You have to eliminate them.
both. Yes,
Tell
sir.
me the differential equation. So let me do it.
That linear, non-linear concept was not clear.
Okay, let me do it first, then I'll come to that also. So number of arbitrary constants are 2, that is a and b. So obviously we need to differentiate equation 2 times. So when you differentiate dy by dx, you will get sine b of x plus cos b of x plus b of x minus b. When you differentiate one more time, we'll get, so it was minus sign.
So e to the power minus ax.
Yeah, did it. So a square e to the power minus ax sine bx plus cos bx and minus 2a times of minus ax b sine bx. So and the last one will be minus e to the power minus ax. This will be b square will come out, and from here you can also do that. You can write like this: 2ab e to the power minus ax. So this will be cos of bx plus sine of, oh, I write it reverse. This will be sine of bx, although in addition it will not matter, but from differentiation point of view it will make more clarity. So this will be your 2 times derivative. Now tell me how you can solve this one. See, is this y? Is this y?
Yes, sir.
And again here it is y and here it is y.
Okay. Mm.
So what you want? You want your a and b to be deleted. So how can you do that?
Mhm. Yeah, yes. We can send B inside this bracket, and then we can little bit manipulate the given function, I think. Then we can do it. Let me do it, sir.
Okay, do it.
Minus 2 a, a to the power minus h, take a
Manas,
b.
Manas, please mute yourself.
Oh, sorry. Can't solve, sir.
See, this is not that kind of equation in which you can delete your this a and b. It is very clear to you by solving. I have given this
Mm.
example so that you can get the understanding. Sometimes you cannot eliminate a and b. This is a
Yes, sir.
MCQ question. So
We can
for
go with hit and trial with
yes,
options.
we can go with the things that we can delete at least you can say e exponential function and your trigonometric functions. So I hope that you can obviously able to delete, and you can tell the differential equation in terms of a and b. So let me tell you how. See, the first term was y, correct, or any doubt?
No,
This,
sir.
this one is y now.
Mm.
And what about this one? This is minus 2a dy by dx plus a times of y, and minus b square. Any problem? So when you rewrite it, so you will get d2y dx square plus 2a dy by dx plus a square plus b square to y to 0. So this is the differential equation that we can at most get. Is it clear?
Yes, sir.
Now let me come to that non-linearity concept someone is asking. So what is your doubt exactly? Can you tell us so that we can precisely discuss that point?
Because product of dependent variable and its derivative should not appear.
So this line, see, dependent variables, I am saying there should not be y square y cube type terms also, and there should not be y dy dx type terms, or you can say dy by dx whole square is also. Is it clear now? What is the meaning of no product of dependent variables and you can say its
So
derivatives?
y squared also should not appear.
Yes, y square should also not appear. That's why we wrote no product of dependent variables slash or. This should be the case. Any one of the case if will occur, then the equation will not be linear. Okay.
So these Bernoulli's differential equation, they are all non-linear.
Wait.
Bernoulli differential
Yeah.
equation.
I understood your point, but can we come back to the Bernoulli equation in the last of the class, because I have a sequence to do.
No, is it a non-linear differential equation?
You
But
tell
it
That is
me.
is
what.
converted into linear. But it is converted into linear. No?
But it can be usually it is non-linear, but we can
But
convert
it can
into.
convert it into.
Shall we move to the next one, or you have some more query?
In the next problem also, you can
Sir,
take
dy dx is equal to sine.
Yes.
in the next problem what you have solved, we have not eliminated both A and B.
See, I have this is the MCQ question. So it was given four options that obtain the differential equation out of these. So I have given this example in the point of view that you cannot eliminate in this kind of scenario this A and B. I didn't meant like this is you can always delete like that. Okay. this motto of this question is to see how we can eliminate this exponential and this sine function in this scenario. Okay. So what is the general and particular solution of a differential equation?
General solution will contain arbitrary coefficients,
Coefficient or constants?
constants as coefficients of some variables, and particular solution will not contain
Uh,
arbitrary constants.
like it cannot contain any, or it can contain some.
In which case,
See, suppose you have an arbitrary constant and I'm giving value to the one arbitrary constant. Will it be a particular solution then, or will
mm,
it be still a general solution?
still a general solution.
Okay. For example, I'm saying I'm giving you some sine.
Am I correct, na, sir?
I don't think so. That's why I'm writing. Suppose this is your solution for a differential equation, and I'm saying C1, C2, and I'm giving value Cn to be 1. Will it a general solution or a particular solution? Anyone? See, it will be a particular solution. So let me mention how. So
Sir, we do not know the corresponding differential equation.
yeah, obviously I know. I'm saying you have nth order differential equation and it is your solution of the differential equation. So you are having
Okay.
n order constants. Okay. So solution containing n arbitrary constants, or more precisely n independent, they should not depend on each other. And I'm saying this for a differential equation. Suppose f x y, y dash, y double dash, and so on, yn. So obviously there must be n arbitrary constant, and particular solution means solution by giving particular values to one or more of the independent variables. Even if you are giving particular value to the one arbitrary constant, then also it will be counted as particular solution. Is it clear?
How, sir?
See,
Um,
general solution means it is in general. uh, in the previous classes
sir,
you have asked
I
about,
can I can understand.
let
Okay,
me
sir. Okay, sir.
complete my explanation. In earlier classes, if you remember, you have said about something about bounded functions. So I
Mhm.
told you anything is bounded if it is holding for, any function is bounded if it is holding for every element of domain. If there is one element there for which it is not bounded, then we cannot say it is bounded. Okay.
Yes, yes, yes.
So
I remember the doubt.
in the same way, if you are saying that something is a general solution, that means if your equation was of nth order, then you must have n arbitrary constants. Okay.
Mm,
If you are having one less arbitrary constant, in that scenario you are assigning a value to an arbitrary constant, so it will be a particular solution. It will be counted as particular solution. Okay.
okay, sir. Well, like let's say the particular solution is so let's say the general solution is a 3-degree curve.
Hmm.
3-degree curve, then basic 3-degree polynomial. So we have 4 coefficients.
Okay.
Uh, so I'm giving one coefficient a constant like 4. So at 0, comma 4, the graph will pass. So I am little bit generalizing it, little bit particularly saying that this should pass from this.
Yes.
That's why we
Yes.
count is not in general. We count,
Yes.
we say it in particular.
Correct.
Now
Correct.
clear, sir,
Correct.
clear.
Okay. Now, next question is how to find out this solution of the differential equation. So obviously, we start with the basic method, that is variable separable method, with some example. So find the particular solution of dx by dy is equal to ln y comma y0 x0 is 1. Now what is the variable separable method? Obviously by name you can guess, separation of variables. So you need to separate these variables and you need to integrate it. So dx by dy can be written as e to the power x and e to the power ln y. Now dx by dy can be written as y times e to the power x. E to the power minus x dx is equal to y dy. So what it will give to you, if you will integrate both the sides, what you will get? Minus e to the power
Minus times e to the power minus x is equal to y square by 2 plus constant.
plus constant. It is a general solution. General solution. Now you know that x0 is 1. So put these values. That means minus e to the power minus 1 and 0 square divided by 2 plus constant. Then what will be the value of c? So this will give you minus e to the power minus x y square by 2 plus, or in fact minus e to the power minus 1. So if you will write or solve this, what you will get? E to the power minus x, this will be minus, or you can say 1 by e minus y square by 2, and from here you will be getting 2 minus e y square divided by 2e. Then your x will be ln 2e minus 2 minus e y square. I hope my calculations are correct. Quickly check this, then we will move to the next one. Any doubt? Okay, then let me move to the second method, or you can say directly right, exact differential equation. What is exact differential equation?
Again, first go with homogeneous, sir.
Sorry, homogeneous.
Homogeneous. Yes, sir.
uh, I hope that is not that much difficult, or you want me to discuss?
No, no, it is easy.
It is easy and examples are given in the lecture, so I'm skipping that.
Okay.
Exact differential equation is more popular and
Hmm.
more intensive to discuss, so I'm discussing it.
Yes.
So tell me, what is exact differential equation? See, whenever your equation is given like m dx plus n dy equal to 0. This equation is said to be exact if you have a function f of xy such that whenever you are derivating it, it will give you this one. And what is the meaning of this derivative? Meaning of this derivative is del f by del x dx del f by del y dy is 0. So from here, if you will see that your m is nothing but del f by del x and n is del f by del y. This we will use for the finding out the solution. And whenever your equation is exact, to check this, there is a necessary and sufficient condition. What is that? Necessary and sufficient condition. What is necessary and sufficient condition for a differential equation to be exact?
df over dx minus df over dy should be 0.
So we say that m dx plus n dy is equal to 0 is exact if and only if del m by del y is equal to del n by del x. If you will derivate this equation, you will get to know. When you will differentiate with respect to y, what will you get? Double derivative of f with respect to first x then y. Here the order will be reversed. If you are saying your function is continuous, then both of the values should be equal. That means I am saying del f del x del y is equal to del 2f del y del x for a continuous function. So from this you are getting this, your necessary and sufficient condition. Now how to find out the solution of this differential equation? See, the direct trick is that calculate this one n minus, or you can say
The coefficients, the terms which are not containing y.
all those terms y or
Sorry,
x,
not containing x, my bad.
all those terms not containing
X dot dy.
x, dy is equal to constant. So on the behalf of this, find the solution of given differential equation 2xy dx plus x square plus under root y dy is equal to 0. You try this one. I'll be back in a minute.
Completed, sir.
What is your answer?
X square y plus 2 by 3 y की power 3 by 2 is equal to constant.
Okay. So obviously we can go by this, but I'm telling you the traditional approach. Del m by del y will be del n by del x will be, so del m by del y is equal to del n by del x. So this tells us the given differential equation is exact. Now what is mdx? 2xy dx. So obviously we are integrating with respect to dx, so we should treat y as a constant. So it will be x square y plus constant will be in terms of any function or any parameter or any independent variable or not. Tell me. I am integrating with respect to x. Then your arbitrary constant will be a function of y. If you differentiate any equation partially with respect to x, that means your y will be treated as constant. So it will become 0. Now, you know that your f will look like this. But what is, suppose giving you this name f. What is del f by del y? What is del f by del y? This is x square plus g dash of y. These things I am getting on the behalf of our necessary and sufficient condition. This one. So n is del f by del y. So this was del f by del x. So this should match n. And what is your n? X square plus under root y. So this should match your n. Let me write like this. N. And n has value x square plus under root of y. So from here you can clearly see that g dash y is nothing but under root y. Suppose if you are getting here is a function of x also, that means you have made some mistake or your given equation is not exact. So from here you will get gy as integration of under root y dy, and you will get 2 by 3 y to the power 3 by 2 plus some constant. Now you can say this constant is only a number, because earlier you have treated as with respect to y. Now since your function is a variable of only your function is depending on only one variable. Manas, please pause your video. Thank you. So your function is depending only on one independent variable, therefore the arbitrary constant will be a number, real number. So now you know that what was your fxy earlier. Your fxy was x square y plus gy. Put this value, x square y plus 2 by 3 y to the power 3 by 2 plus constant. This was from the traditional approach, and in general if you want to write, you can directly do this one. Terms in n not depending, not containing, x, this will be constant. So m dx was x square it was x d x y 2xy dy. So it was 2xy dy.
It will always give constant coefficient, na? Yeah, seen in
Yes,
the proof, na?
in this case it will be always be a constant coefficient.
Yes, sir. We have
Okay,
seen in the proof.
but with the traditional approach there is something different that I want to tell you about.
Yes, sir. This is the actual proof.
Yes, so what is the term that is not depending on x? That is only under root y. This will be under root y. Dy is equal to constant. So obviously your output will be the same. Just I want to give you the glimpse of different approach, or you can say proof. Is it clear? Now it is not always possible to solve the differential equation, or the differential equation is in the exact form. So okay, let me give you one more uh, form of this exact differential equation. Find the non-zero value of n for which the differential equation 12x y square plus n square x square y dx plus 2nx cube plus 12x square y dy equal to 0 become exact. So we need to tell the value of n for which your given equation become exact. So you need to calculate the value of n. Try this one.
Six.
Correct. So del m by del y 12xy square plus n square x square y will give you 12y square plus 2n square xy del n by del x 2nx cube so this will give you 6n x square. Okay, yeah, here we have to differentiate with respect to y, so this should be n square x square, so plus 24, we are differentiate with respect to y, 24xy. So here should be also, we are differentiating with respect to y to 24xy. So if equation is exact, then del m by del y must be equal to del n by del x. So that means you are left with 6n x square is equal to n square x square. The other two terms will be cancelling out. So from here you will get n square minus 6n into x square. It must be 0. So obviously we want the value of n. So n can be 0 and 6. So since we want non-zero value, it will be 6. Is it clear? Now our next task is to discuss about integrating factor. Sometimes your equation is not the exact in the exact form, but after multiplying or after doing some factor, it will become the exact. So what are the different forms of exact integrating factor? How can we make a differential equation exact with the help of integrating factor? Tell me, what are the four different forms of integrating factor?
Integrating factor we compute like e to the power integral p dx or
So
e to the power
suppose,
integral p dy. We found it by partially differentiating and subtracting and then dividing by the function.
so first is this like this, del m by del y, del n by del x divided by n. If this is a function of x only, then what will be the integrating factor? E to the power, let me write f for g something, fx
Integral f dx.
dx. The second case is if del n by del x minus del m by del y divided by m. If this is a function of y only, then integrating
E to the
factor
power integral gy dy.
gy dy. Is there any other third form? One is, suppose m dx plus n dy is homogeneous and mx plus ny is non-zero, then integrating factor will be the last one is if your differential equation is of the form f1 xy y dx plus f2 xy x dy is equal to 0, then 1 by mx minus ny, this will be the integrating factor, but mx minus ny should be non-zero. Okay, and one another is some terms of x to the power a or y to the power b, like kind of in that scenario you need to substitute and check. So let me give you one question regarding this. Find the integrating factor of the following differential equation plus first of all check whether this equation is exact or not, and if it is not exact then find the integrating factor.
Sir, 1 by y.
1 by y, correct, 1 by y is correct. So del m by del x is del n by, sorry, del m by del y 2y, del n by del x is y cube plus xy. So this will give you y. So clearly both are not equal, so equation is not exact. So you just need to check del n by del x by del m by del y divided by m. How it will work, it will work or not, we will check this one. So this will be y minus 2y divided by y square. So this will give you minus 1 by y. So clearly this is a function of y. So this is a function of y. So we were denoting it by g. So let me denote it by like this. So integrating factor will be e to the power minus 1 by y dy. So e to the power minus log of mod y. So e to the power ln of 1 by y. So here we may assume that your y is positive. So this will be 1 by y. See, in the case of integrating factor, we are not considering the arbitrary constant. We are assuming that it to be 0. Or obviously, that can be also work as integrating factor in that scenario. So we are just only working with this integrating factor. So this will be your integrating factor for your differential equation to become exact. Now, how to solve with the help of this integrating factor approach? So let us discuss one example regarding that. Question number 7. Find the general solution of the given differential equation 2x dx plus x square plus y square plus 2y dy. So you know how to solve this kind of equation. If it is exact, then you can solve it directly. Otherwise, you need to follow the integrating factor approach. So try this one and tell me the answer.
e to the power x into x minus 1 is equal to constant.
E to the power x into x minus 1.
Yes, sir.
No, it is not correct. Try again. I'll be back in a 5 minutes, so try this one. You got any answer? No, e to the power minus 5 is not the answer. Did I wrote the equation correctly? 2x dx. Yeah, this is not the answer. Does the equation is exact? So from here, del m by del y will be del n by del x will be Now del n by del x minus del m by del y divide m will give you 2xy minus 0 divided by 2x. So integrating factor will be e to the power y dy. So e to the power y will be your integrating factor. So your equation now will become 2x e to the power y dx plus x square plus y square plus 2y e to the power y dy. Now you can check your equation becomes exact or not. So del m by del y will be del by del y of 2x e to the power y del n by del x will be x square plus y square plus 2y e to the power y, so it will give you 2x e to the power y. So now the updated integration equation is exact. I'm saying this as star. Star is exact differential equation. Now if you know the exact differential equation, so you know the solution also. M dx plus terms that are not containing x equal to constant. So what is m dx? 2x e to the power y dx. Those terms that are not containing x, what are those terms? Y square plus 2y e to the power y dy is equal to constant. Any doubt? Now do the integration x square e to the power y plus, what is the integration of this y square plus 2y e to the power y?
We will go with by parts.
By parts. E square e to the power y minus 2y e to the power y plus 2 e to the power y, and again with the other one 2y e to the power y minus 2 e to the power y is equal to constant. Is it correct or I made some mistake?
So let me see the question once again.
See, this is I wrote here. This you need to
I
follow.
think integrating factor will be e to the power x. I think it is in x.
No,
Sir, e to the power y into x square plus y square equal to constant.
just a second. So we don't need to integrate the fully. We can only stop at this point, that this will become 2y e to the power y dy plus you have a term 2y e to the power y dy which is equal to constant. This will cancel out and you will get x square plus y square e to the power y is equal to constant. This is your general solution of the differential equation. Is it clear? Now ask Manas why you are saying this is e to the power x. See, this is the differential equation, and you can calculate del m by del y, del n by del x, and this is the integrating factor. Ask if you have any doubt. Otherwise, we will move to the next question. Okay, if there is no question,
Uh,
then
yes,
yes.
sir. Sir, how? So please check the n. How del n can upon del x is 2xy? It should be 2x only, na?
Okay, okay, okay,
There was mistake, sir.
okay. Wait. Let me check. Okay, I wrote something wrong here. So this was x square plus y square plus 2y.
Plus 2,
This will be
2x
2x.
only.
Thank you.
Yes.
Thank you for mentioning.
2x minus 0 upon 2x, it is 1. And it is, we will treat it like x because we are writing
Yeah,
like so.
here it is a typo. Here I didn't that mistake. That's why it is coming like this. It will be e to the power y now.
No, 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 no. It should be y. We are going with this one, na? 2x m. We are using this 2x minus 0.2x is equal to 1. We will treat it like y, na?
So that is why
I'm confused. Y or x
see.
and
These are four
yes,
methods.
yes, yes.
In the
एक
first
second, sir.
one, you need to consider like this. If you are considering like this should be a function of y. So we are considering this one.
And last one is last. Yes, rotation पे change होगा. Okay, okay.
Yes,
Yes, it should be to the power y.
e to the power y. After that,
Hmm.
we have wrote it correctly. So the error was like at these 2 points that you have already mentioned. Thank you for that. Now, if you have something more to ask about this, then please discuss.
No, sir, it is done.
Okay. So as I told you, there was some other kind of integrating factor x to the power a or y to the power b kind of. So I'm writing that. Let x to the power alpha y to the power beta be an integrating factor of the differential equation y cos of xy dx x cos of xy dy. So tell me, find for which value of alpha and beta the given differential equation is exact. It can be the constant value alpha beta, or it can be some case in which you got some relation between alpha and beta. So let me just precisely write, find the relation between find the relation between alpha and beta such that the given differential equation becomes exact.
Is there any typo, sir?
I don't think so.
I found this to be exact.
Is this already exact?
Yes.
No, it will not. Please check. Type 4, but it will be 0. What does that mean? Mx minus ny. So it will not work, na? It will work only in the case of when mx minus ny is not equal to 0. See, I'm telling you already that integrating factor has of this form. You need to find the relation between alpha and beta, so that after multiplying this with the differential equation, you will get the differential equation is to be exact.
Sir, alpha equal to beta.
Correct. So when you del m by del y, you will do y, you will get plus xy so from here that's why you are saying that it is exact.
Yes, sir.
hmm. I hope I did not made any calculative error. Hmm. This is exact already, but since we have been said, suppose this is a integrating factor, so let
We
us,
can do by multiplying that
we can do
and doing
also
so.
in that way.
Then we can find, yeah, then we can find that alpha is equal to beta.
Yes, cos of xy dx so del by minus minus. That is why also we are getting this simple relation, because it is already exact. Therefore alpha must be equal to beta for this integrating factor to behave like integrating factor. So let us move to the next one, that is the simple you can say linear differential equation. What will be the integrating factor in case of simple linear differential equation? Can anyone guess? What is the integrating factor? I am saying, suppose you have a equation this kind. What is the integrating factor of this equation?
T to the power integral p dx.
And what is your solution?
Y into if is equal to qx into if integrating. Integration of qx into if with respect to x.
So on the behalf of this one, I am giving you one example or question. So find the solution of the differential equation dy by dx plus 2xy is equal to
Y into e to the power x square is equal to x plus k.
correct.
Yes, sir.
What is px here?
2x
Qx.
e to the power minus x square.
So from here integrating factor will be, so solution will be is it clear?
Yes, sir.
Now let me give you one more question. This is kind of the previous one, but the thing is that this is not directly the linear form, but you need to convert it some sense, just like Bernoulli. In Bernoulli you substitute 1 by y to the power n something, so same like this you need to substitute here something.
Sir, find a general solution or find the general solution?
I'm sorry, it should, since it is unique, so it should be the general solution. Thank you for such a keen observation. So if you divide this whole equation by cos square y, what you will get?
Sir, can I say sec y into e to the power x is equal to e to the power x plus c?
E to the power x sec y equal to e to
To
the
the
power
power.
x plus c constant.
Plus c.
Yes.
10y, here it will be
Done, sir.
sec y is equal to e to the power x. Now put
10 minutes.
Sec y is equal to t.
some z.
ওইখানটা গরম।
So from here you will get sec y 10y dy is equal to dz. So it will be dz by dx plus z. So integrating factor will be solution will be z into e to the power x into e to the power x dx. So this will give you e to the power x plus some constant, and you know the value of z, that is sec of y e to the power x Is it clear now?
Sir, can I ask one question?
Integration is not like this, no? E to the power, we can write it like e to the power x plus e to the power x, and then we can do simple integration, and then by division 1 plus e to the
So
power x.
obviously here you have to substitute e to the power x some t, and e to the
Uh,
power x dx will be that substitution, so it
dt.
will be e to the power t dt. Then the answer will be again this. So that's why I just skip those steps. Yes, you were asking something.
Sir, actually, I want to ask how can I access, if required, these classes in future?
So there is a link now. The
How can I
entry.
get that link?
So
in session folder, in each week, in last, there is week wise folder, week 1, week 2, week 3, and then in bottom of the left hand column, we have this problem solving session folder where we can see this.
Using laptop or using mobile? Is it accessible through mobile?
Anything, yes, it is.
So where should I go first?
Let me tell you. Come on, man. Go to the course.
Huh.
Okay.
Course?
Okay. Wait, just a second. Left hand side, the bottom left corner, problem solving session July 2026.
Okay, I will try.
There are two sections. One is recording section and one is survey sections where you can share feedback. And in problem solving session, there is a link which goes to I think Excel file. Excel file where you can find the recordings, attendance, and PDFs of the class notes.
Also. So initially through course, then bottom left hand side, there will be a problem solving session button.
Yes. And bottom problem solving session, July 2026. In that folder, you have two subfolders, problem solving session recording and survey.
Okay. Thank you.
Okay. Thank you.
So any other query regarding the problems?
No, sir.
So I want to mention that as per the correction by Muthu sir, we have updated the PDF of week 3. So
Yes, sir. No. Seen.
you can also go through that. There was some error in week 3 one problem, so I have updated that. Okay.
Yes.
Okay then.
I have attached the. So I'm telling to sir. I have attached the sir link to that spreadsheet where you can find a recording and PDF of this lecture notes. I mean, this recording slide classes.
You can
But
save it, Biswajit for further.
but they have not changed the assignment marks.
Actually, sir, I cannot get like I did not tackle that point. So you need to ask them or mail that in that group also. You can do only that thing. So my task is to take live problem solving session only.
Thank you.
Yeah. Any other query?
No, sir.
Okay
All
then.
fine.
Thank you. Let's meet on the next Tuesday.